Lesson 16.1, Task 5. Create models with sine and cosine functions. All right, so now we're going to talk about frequency. Okay, frequency equals 1 over your period. So let's look at the definition here. Sine and cosine functions are useful for modeling real-world phenomena involving periodic behavior such as sound waves. Each sound has a frequency, which is the number of cycles completed in a given unit of time. Since the period represents the amount of time it takes to complete one cycle, the frequency in the reciprocal of the period, or is the reciprocal of the period. The standard measure of frequency in hertz, which is equivalent to 1 cycle per second. All right, a tuning fork is a simple metal probe that, when struck, emits a constant tone. Musicians use them to tune their instruments. Different sized tuning forks vibrate at different speeds and cause fluctuations in the air pressure. This fluctuation has a maximum that is related to the sound wave's amplitude. The change in air pressure is typically measured in pascals. For each sound wave, determine the frequency. Write an equation to model the air pressure as a function of time and graph the function. Use a sine function to model a sound wave with a period of 0.0025 seconds and an amplitude of 3 pascals. All right, so to do that, we're going to identify the frequency. Remember, the frequency equals 1 over the period that was given right above. And in this case, that would be 1 over, this is the number that is given. So it says it has a period of 0.0025. So all we have to do is plug that in and then see what that is. All right, so write an equation. So we're going to have P of t equals 3. Okay, that was given as well. So that's your amplitude, and it says amplitude of 3, so we're going to put 3 sine of, and it's going to be 1 over b, so remember that's 2 pi times b, and then we can simplify this a little bit because we want it to look like just as simplest form as we can. We don't normally have a fraction and a decimal together. So you can see they still have it in terms of pi times t, but let's see what is 2 divided by that decimal. And I'm sure it's 800 since that's what they have, but that's what we want to do. So we want to do 2 divided by, because again, we don't normally have a decimal and a fraction together. It just doesn't go well in math. So we're going to simplify that to 800. So 2 divided by that is 800. So that's how they go from this line here to this line here. They just cleaned it up a bit. So P of t equals 3 sine of 800 pi times t. All right, and then if you wanted to graph the function, all right, you could do that. And you can see how here is 0.002 and here's 0.003, and halfway between 002 and 003 it crosses right here. So you can see that's where this number came from, this 0.0025. So it goes from 0 to 0.0025. You can see that is one complete cycle. So that's where the period came from, was that horizontal distance there. All right, and the amplitude, you can see, goes from 0 to 3, and then this is the midline, so it would go also down to -3. All right, so there's a second one here, and it says use the cosine function to model this sound wave. And it has a period of 0.005 and an amplitude of 2. All right, so again, we're going to use the frequency equals 1 over period to determine what this is. So we're going to do 1 over, and this 0.005 is given. And we're going to put this in here. And again, the amplitude is your A, so it goes first. So P of t equals 2 times cosine of 2 pi over this number they give us above times t. Now again, we're going to simplify that. We're going to leave it in terms of pi, but again, we're going to divide 2 divided by that decimal. So 2 divided by 0.005, and that gives us the 400 that they have here. Okay, now again, you're going to see that one complete cycle or one rotation goes through at, this is 0.004, this is 0.006, so right in here would be 0.005. So you can see from here to the bottom and back to the top, it starts a new cycle at that point. So that distance from here to here, that's your period. And this one complete rotation is your cycle. So that's where that comes from. And then again, your amplitude goes from the midline to the highest point. So that 2 comes from right here on the graph. And then if you do the absolute value and you go down, you're going to see that goes down to -2 as well. So if you know the period and the amplitude, you can sketch the graph of your function. So it says, how are the period, frequency, and equation related? So the period is affected by the value of b and the frequency of the reciprocal of the period. The coefficient of t in the equation is the product of is it amplitude, is it its frequency, and 2 pi. So the coefficient of t, okay, so look back up here. The coefficient of t, that means the number in front of t. So that's going to be the frequency times 2 pi. So you can see the frequency here was what they gave us, the 0.005. Actually, the frequency, we found it given the period. 1 over the period equals the frequency here. So that is why this would be the frequency times 2 pi. How to use the period and amplitude to graph each function. Use the period to determine the horizontal. Remember, the period is your horizontal. It's on your x-axis, distance of each complete curve. And use the amplitude to determine the vertical, or the A, on each line. So that would determine your maximum or minimum. All right, that's all for task 5. If you have any questions, let me know. Lesson 16.1, I'm just going to show you an extra example here. Make sure that you know how to go from the unit circle to a table to a graph. So looking at the table, this is the table we were given in task 1, I believe, or at least one of the tasks. And I want you to see that, well, first remember that the cosine and the sine come from your xy values. So they're your exact points. So if you have an ordered pair, x and y, when we're dealing with the unit circle, it's always cosine of x and then sine of x. Sorry, sine is your y. I'm not going to put x's and y's. I'm just going to put cosine and sine. All right, so it's like an ordered pair. Your x value is first, your cosine is first, your y value is second, your sine value is second. So when we're looking at the unit circle, to determine what this table of values is, so at 0, 0, remember the sine is the second value in your ordered pair, so that's why at theta 0, f of x, or f of theta, is also at 0. So that's 0. And then pi over 6 is my 30-degree angle. So my second value, or my sine function, is 1/2, or 0.5. At pi over 2, that's at 90 degrees. My second value in my ordered pair is a 1, so that's where that came from. 5 pi over 6, 5 pi over 6, my second value is 1/2. Pi is at 0, you can see, and so forth. So your y values right here, f of theta, come from the y value in your ordered pair. Now, if you were doing cosine of theta, it would be very similar, except you would look at the first number in the ordered pair because cosine comes from x. All right, now how do we take the table or the unit circle, because the table is just part of the values from the unit circle. So how do we take that and sketch the function? So this is just f of theta equals sine of theta. So this is just my parent function. This is the most basic sine function that comes from the unit circle here that we have given. All right, so we're just going to take, I've got some basic graph paper here that's been labeled with trig functions instead of numbers. So we know that pi is about 3.14, but we don't need to have 3.14 on here. Since our unit circle is in radians, we're going to make our table or our graph just label it in what we're given, which is radians. So at 0, 0, we're going to have a point. So let's put a point at 0, 0. All right, at pi over 6, that's 30 degrees. We don't have pi over 6 here, but we do have pi over 2. So you don't have to have exactly every point on here. So we can go to pi over 2 as 1. So let's say this is 1. Let's say this is -1. So this would be, actually I'm going to move it down just a little bit. So when you have blank graph paper, you can make your scale anything you want. I'm going to put 1 right here. That way this would be 1/2 or 0.5. And then this would be 1.5. All right, so if we know that that is 1, so at pi over 2, I have a point at 1. All right, 5 pi over 6 is not on here, but pi is, so pi is back at 0. And then 3/2 pi is at -1. And then you can see 2 pi is back at 0. All right, so that gives us enough points to sketch the curve. And you can see that the curve will go just like the other curves. And you can actually put an arrow on here to represent that it will continue if you go more rotations around the unit circle. So see, even though I didn't have all of my points on here, I know that pi over 6, it's going to be right in here somewhere because it's at 1/2. So wherever 1/2 is going to be, actually, yeah, it would be about right there. And so, because 30 degrees is 1/3 of 60, so that fell. I actually sketched that graph pretty good. All right, anyways, that's just if you need to sketch a graph on your own. If you have a table of values, just put the ordered pairs on your graph like any other graph, and you can sketch a basic trig function. All right, that's all for lesson 16.1.